Yes, hello everyone. I'm Sushant, studying in Sri Venkateshwara College of Engineering, Vidyanagar Cross, Bengaluru, Department of Information Science and Engineering, and my USN is 1B23 IS048. Subject Analysis and Design of Algorithm. Topic The Greedy Method and Dynamic Programming. Subject code BCS401. So today we are going to discuss the greedy method and dynamic method of algorithm. Introduction. The greedy method is a problem solving paradigm, builds the solution piece by piece, chooses the locally optimal option at each step. Goal: achieve global optimum by local choices. The features of greedy method: fast and easy to implement, no backtracking or recursion, makes decision based on current information, works for problems with specific properties. Next, the greedy method properties. The greedy choice property: a global optimum can be arrived at by choosing local optimums. Optimal substructure: an optimal solution to problem contains optimal solution to sub problems. Next, general structure of greedy algorithm. Sort or prioritize the input, instalize an empty solution set, iterate and make the best possible choice, check feasibility and update solution, repeat until all elements are considered. Comparison: greedy versus dynamic programming. So we discussed how the comparison between greedy and dynamic programming. Greedy method: top down, no backtracking, usually lower time complexity, not always optimal. Dynamic programming: bottom up, uses memoization. So we can discuss the example 1, activity selection program. Goal: select maximum number of non-overlapping activities. Approach: sort activities by finish time. Always pick the next activity with the earlier finish time. Greedy works due to optimal substructure. Example 2, fractional knapsack problem. Each item can be broken into smaller parts. Strategy: calculate value weight ratio. Sort items in decreasing order of ratio. Pick highest ratio items first until capacity is full. Example 3, Huffman coding. Used in data compression strategy. Build a min heap of frequencies. Combine two lowest frequencies nodes repeatedly. Greedy choice minimizes total cost of encoding. Greedy algorithms in graphs. Prim's algorithm, minimum spanning tree. Kruskal's algorithm, minimum spanning tree. Dijkstra's algorithm, shortest path, non-negative weights. Advantage and limitations. Advantages: simple and efficient, easy to implement, works well for many real-world problems. Limitation: not all problems can be solved optimally, needs carefully analysis of problem properties. Real world applications: job scheduling, network routing, resource allocation, file compression, minimum spanning trees in networks. Conclusion: greedy method is a powerful algorithms technique, efficient for problems with the right properties, always verify. Now we discuss the introduction of dynamic programming. What is an algorithm? Why efficiency matters? Brief overview of optimization techniques. Now, what is dynamic programming? A method for solving complex problems by breaking them into simpler subproblems. Overlapping subproblems plus optimal substructure. Contrast with divide and conquer. Characteristics of dynamic programming: overlapping subproblems, optimal substructure, memoization versus tabulation. Steps to solve problems using dynamic problem: define the state, what are the recurrence relation, identify base cases, implement top down or bottom up. We should discuss now. Example problem: Fibonacci sequence, recursive versus dynamic programming approach, time complexity comparison, recursive, dynamic programming, include code snippets. Applications of dynamic programming, shortest paths, Dijkstra's and Bellman-Ford, knapsack problems, longest common subsequence, matrix chain multiplication. Analysis of algorithm efficiency, time complexity, big O notation, space complexity, best worst average cases, trade-offs, time versus space. Comparing algorithm efficiencies, algorithms, time complexity, space complexity, recursion, dynamic programming top down, dynamic programming bottom up. Props and concepts of dynamic programming. Efficient for optimization problems, avoids recomputation, requires understanding of programming, can be memory intensive. Conclusion, dynamic program is a powerful technique for solving recursive problems for efficiency. Algorithm analysis helps choosing the right approach